So this is a story about the weather we got in the last 2 days recently in January. So today is Tuesday, January 17th, and in Winona there wasn't any school. And on January 16th there also wasn't any school. That was Martin Luther King Day. And both days school was canceled because of the horrible weather. Um, so this is a picture from the Twin Cities, but every road in Winona looked basically like this, like a giant skating rink, and you couldn't go anywhere. And it was raining like crazy both days, and everything just froze. So the sheriff's office actually said there were some vehicles that actually got frozen into the road, so they just didn't even move because they got locked up. Um, so the part that's relevant to our class is that when they were so they canceled school on Monday, and then about 8 o'clock on Monday they said it's going to be a late start on Tuesday. And I heard that and I thought, there's no way they're not going to cancel school tomorrow on Tuesday. I thought that on Monday um, because of how the gravel road outside of our house looked. I thought there was no way that the rain would melt the ice and the gravel um, that we had outside. I thought there was no way that the rain would actually thaw the road out. Um, so to elaborate on that, here are some short calculations. So first off, if you make a graph, and I know this is kind of busy, so if you make a graph of what happens to water, like as you add heat to water, how does the temperature change? Or as you change the temperature of water, how much does the heat it contains change? Um, in room temperature, that's a straight line. So twice as much temperature increase, twice as much heat is stored. So for liquid water, that's a straight line. And the slope of that line is about 4 joules of energy for every um, gram of water that you have. So you can see the rise is the energy and the run is the Celsius. And this story is for a gram of water. Um, and so um, if you have rain that falls and the rain goes from 36 to 32 when it hits the ground, right? Like the rain hits the ground and it cools down from 36 to 32. So that means the temperature drops by like 4 degrees Fahrenheit or 2 degrees Celsius. And most of the science calculations use Celsius, so that's what I'm using. Um, and so, oops. So since water has a density of 1, like a gram of water has a volume of a cubic centimeter, you could think of it like this. Like there's a little cube of water, a centimeter on a side, and when that cube of water falls and sits on the ground, right, a little cube of water, which is kind of goofy, right? But imagine the whole ground is coated with these cubes of water. So every cube of water, so per square centimeter, you deposit about 8 joules of energy. And so for now, a joule is just a unit. Actually, in Canada, Snickers bars, the nutritional content is rated in terms of thousands of joules. A dietary calorie is also related to thousands of joules. It's just a unit of energy for us. Um, so the takeaway from page 1, a square of water, 8 joules of energy, right? A square of rain. So what happens to the road? So if you think about the road being, crushed limestone, that's what it is around here. They just, quarry limestone and crush it up and makes a nice road base. That also has a graph of energy versus temperature that's like a straight line. And the slope, instead of being 4 joules per gram Celsius, it's like 0.91 joules per gram Celsius. So if you want to think about material storing energy with temperature, limestone stores about a quarter as much energy as water does when you raise its temperature. Now I looked this up on the internet because I didn't know. It turns out that if you have a cubic meter, so that would be 3 feet by 3 feet by 3 feet, a cube of gravel, that has a mass of about 1,600 kilograms, which is your average Toyota Corolla. That's how much mass is in a cubic meter. And so, if you think about the proportions we worked with the other day, if you have a gram of gravel, because remember the slope uses a gram, if you have a gram of gravel and you multiply by this proportion, so a cubic meter is 1,600 kilograms, and then you multiply by a proportion to get rid of kilograms, right? So 1 kilogram over 1,000 grams. And then you multiply by a proportion to get rid of meters, so 100 centimeters over a meter 3 times. You get that a gram of gravel has a volume of about 0.625 cubic centimeters, right? So this is mathematically, we're doing a lot of calculations. Stay with us. There's a good story at the end. So all this math to say, a gram of gravel, 0.6 cubic centimeters. So you could think, does that make sense? Do rocks sink in water? A gram of rock has a smaller volume than a gram of water. So maybe that helps you think about the number and say, yeah, that makes sense. Rocks sink. Or you could divide both sides by this number and get that a cubic centimeter of gravel is 1.6 grams. So the same volume of water, the volume of gravel, volume of water, the gravel has more mass, right? It sinks. So how do we use all this? Well, that slope was 0.91 joules per gram Celsius for gravel. Oh man, gotta stop doing that. So the same slope could be 1.5 joules per cubic centimeter of gravel per degree Celsius. So all that math was basically to get rid of that gram, measuring gravel in weight, and turn it into cubic centimeters. So now measuring gravel by how much space it takes up. All right, so let's go back. Remember on the previous page, water was 4 joules per cubic centimeter. Gravel is 1.5 joules per cubic centimeter, right? So water stores maybe 3 times more energy than gravel does. So let's tell a story. If you have a cubic centimeter of rain, and it falls on the ground, that means you're depositing 8 joules in that little block of rainwater, right? 36 Fahrenheit to down to freezing. So that's 8 joules. And then if all of that energy goes into the gravel, how much does the gravel warm up? So remember the slope of gravel's energy versus temperature graph is 1.5 joules per degree Celsius per cubic centimeter. So we're talking about the same volume. And then it's like an equation because you got joules per Celsius per volume times how much does the gravel warm up. So you divide both sides by 1.5 and the gravel warms up by like 10 degrees Fahrenheit, 5 Celsius, 10 Fahrenheit, right? It really warms up a lot. So here's part one of the story, right? Conclusion one. If it's raining and the road is dry, it might actually be possible that the rain doesn't freeze on the road. If the road is dry, the rain can actually warm the road up by as much as like 10 degrees Fahrenheit if it's a half an inch of rain. A half an inch is about a centimeter. But here's the thing, every road in Winona County was covered with like icy snow, and the rain was falling on icy snow. So we have to fix our story. So here's me fixing the story. So ice, oops. So ice is about 330 joules for every gram of ice, like if you want to melt ice into water. And the density of ice is slightly less than water, right? It floats on the top of lakes, it floats on the top of your Coke. So you can work out that, dang it, you can work out that it's about 300 joules per gram to melt ice. So you got a little cubic centimeter of ice. You've got, oh, it's a typo. I'm sorry. This should be 300 joules per cubic centimeter. So 300 joules per cubic centimeter. So like a little cubic centimeter block of ice takes 300 joules to melt. So let's try that story just a little bit more. So you got a road, and it's got a centimeter of ice, a half of inch of like icy snow on the surface. How much does it have to rain to melt that icy snow? So here's the story, right? You've got a centimeter cubed of ice. It takes 300 joules per cubic centimeter to melt that ice. And the rain, right, 36 Fahrenheit down to freezing, that cold rain is 8 joules per cubic centimeter. So if you want a picture, you could say, okay, so if I want to melt this ice, I need 300 blocks of energy, right, 300 joules. And if I'm finding that energy in little blocks of rainwater, right, every little block is a cubic centimeter and they're all stacked up, I think every block would contribute about 8 joules. So the energy to melt the ice is about 300 of those blocks. The energy per block is 8, so 8 joules per raindrop per cubic centimeter, 300 joules per cubic centimeter ice. So how many of these energy blocks do we need? Like 37. So if you have 37 centimeters of rain that falls, that's enough energy to melt a centimeter of ice. 37 centimeters is like almost 15 inches, like 14.7 inches. So if it's an icy gravel road, you'd have to have 15 inches of rain to fall to melt the ice on top of the gravel road, which is right. When does 15 inches of rain fall in the middle of the winter? Not in January. So conclusion, right? There is no way if it's raining all night, drizzling, that the rain is going to melt the ice on the gravel road. And so if they say, look, it's just going to be a late start tomorrow morning because it's raining all night, that's crazy. There's no way they're even going to have school the next day because the rain won't melt all the ice. So that's the story.